Hey everyone, my name is Christine Javier, and today I'm going to work on FreeCodeCamp's Chunky Monkey. So I'm going to quickly read the directions. You're going to write a function that splits an array, first argument, into groups the length of size, second argument, and return them as two-dimensional arrays. So let's go look at the test case and see explicitly what they're talking about. Here you have first argument of one array that's comprised of A, B, C, and D, and the second argument of 2. So what you should return are subarrays that are comprised of 2 elements in each array and that go in order. So you have A and B, and then C and D that's being returned. These subarrays within one major array. Okay, so hopefully that made sense. Give a good look through the test cases if not, and just kind of gauge what's really happening. I'm going to just copy this function and work in my text editor. Now, before I really get started, let's just analyze and see what our strategy should be here. And keep in mind that FreeCodeCamp here recommends that you're using the slice method, which was a bit challenging, but it was a lot of fun trying to navigate through the solution with that in mind. Okay, so let's see how slice really works. Well, I'll just tell you. The way slice works is it takes in 2 arguments. Now, the first argument tells you where you want to start the slice. So let's say it's going to be .slice 0. That means that you're going to start at the 0th position of the array. Now, the second argument tells you the point that you should stop, but you're stopping one less than that. So I'm just going to give you an example. Let's say I'm going to put in 2. What the 2 actually means here is we're going to count up to the second element. So we have 0, 1, 2. So we're at C. But it's not inclusive. It's exclusive, meaning that this is not counted, so it's only going to slice up to this point. So with this slice here, we're only getting A and B. Now let's just demonstrate that for your visual knowledge. Return r.slice 0, 2. All right, I'm gonna console.log this test here, and let's run it. A and B. Let's say I put in 4. What should we expect? Let's say 2 and 4. So we're gonna start at the second position, 0, 1, 2. So we're starting at C. Actually, we don't even have 4 elements. Well, 0, 1, 2, 3. That's perfect. So because it's exclusive, we're only going to go up to the 3rd element, not the 4th. Let's see what that looks like. C and D. All right, so that's how the slice method works. Now, let's keep that in mind as we're figuring out our strategy. So what the goal really is here is that we always want to start at the 0th position, right? But what's kind of the way we could mathematically configure what's happening? So we start at the 0th position, and we're considering size. So we want to go as far as size in this case, right? Because size is 2. We want to get 2 elements. We're starting at the 0, 0, 1, 2. So because the way slice works, because it's not inclusive, we're just going to get these first 2 elements here. Let's see what that looks like. A and B. Good. Now, that's the first thing we want. We want to capture A and B. But how do we capture C and D? Let's quantify that. Well, A is at the 0th position, C is at the 2nd position. So really what we're doing is we're having 0 plus size, which would equal 2, right? So we got to figure that. And then what does size become here? Well, we want to get the 3rd element. So we're going to do size plus size, which would equal 4 in this case. So that's just a note here. Let's test that out and see if we encapsulate again what we want. Cool. So my purpose in bringing this up is that I want to make a general equation that would work for any test. And so the pattern here is that we're just adding size after each slice to the 2 arguments so that it knows to move on at the right amount of spaces and capture that. Okay, so that's how that's going to work. I'm just going to leave this as a note. So we're going to do first argument equals that. Second argument equals that. And I'll comment that out in a bit, but let's just work through it first. Okay, so let's get really started on the code. Let's declare some variables. And I'm going to execute this code using the while loop. All right, so the first thing I want to do actually is that in playing around with size, you could kind of visualize how second argument here will just compound greatly. So let's say we have, like, if this array is going to be huge, size is going to keep changing like dramatically, and that's not precisely what we want. So for example, in the first round, we have size is 2. Size plus size equals 4, right? Great. But the goal after that is to move, again, just another 2 spaces. So we can't do size plus size again, because now size equals 4. And we're going to have 4 plus 4, and that's going to equal 8. So that's just compounding, when in reality what we want is 6. So in other words, we're going to have to make another variable that's a placeholder value for size. So I'm going to do var placeholder equals size. So now placeholder is going to be the one that's changing, but size never changes. So it's just going to be placeholder plus size. And we could visualize that as we execute through the code, but that's the importance of this placeholder. It's that we want a value that, yeah, it's evolving, but size remains the same, because that's a constant. That's the constant amount of elements we want to trap in this case. And we can't change that because it's going to look like a funky array. Okay, so that's the first thing. Now, because of the while loop, I'm just going to declare a variable called I, and we're going to set that equal to 0, meaning that we're going to start at the 0th position in our while loop. So then we're going to start with a while I is less than. Now, this is the curious part, okay? This is when you really have to do a little thinking here. We want to do r.length, but because we're trapping just a set amount of elements, we don't want to go too far. We want to capture that exact point where we really have just that last starting value to slice all the remaining elements. So yeah, you don't want to go to the very end of the array, because you're going to do a lot of actions to just this element, and that's not what we want. Really, we just want to stop at this element here, at least in this particular case. And we have to write it out such that it's so general that it would apply to other cases as well. So we have r.length. Now we want to do minus size, because then we have the length here of 1, 2, 3, 4, minus 2, which equals 2. So we're going to start at this position here, 0, 1, 2. Okay. I think that should be good. Let's see. But, oh yeah, because of the less than sign, we have to just add 1, because we want to make it inclusive here. So let's really read this out. I realize this could be a little confusing. The way we're going to count in this while loop is we are going to go as far as the length. Okay, so at the very end here. And the length is actually 1 more than the amount of elements. Minus size, so minus 2. So the length is 6. Minus 2 equals 4. So 0, 1, 2. Hold on. Yeah. No, sorry. The length is 4. Then size is 2. So we have 0, 1, 2. So good. We're at this point. The thing is, I is less than that. So it's not going to go up to here. It's going to go only up to 1, because this is only going to be true as long as I is a value less than 2 here. So that's why I'm adding 1, so that it's inclusive, so that it includes just the very last point we want to be working at. Okay, so hopefully that made sense, but if you really think about it, just read through it and write down exactly what's happening with that statement. Okay, so now let's see. We're going to do slice. So let's declare another variable again. We're going to call it answer, and we're going to make it equal to an empty array. This is going to be the master array that holds all of our subarrays. Okay, so now let's see. We're going to do, let's see, answer dot push r dot slice. Okay, now we're going to do r dot slice I. So we're always starting at the ith position, and we're going to go as far as placeholder or size. Hold on. Far as placeholder is ever changing. Yeah, so we're going to do placeholder. Excuse me, I had a brain fart there. It's really hot in this room. Summer is really happening here in SoCal, and bad. It's pretty hot. So if I sound a little weird, it's due to my being delirious in the heat. Okay, so we have that. Now let's talk about how I is changing. So again, we're trying to do first argument is going to increase by the amount of size. So I is now going to be plus equals size. And then same with placeholder. Placeholder is going to be plus equals size. All right. Now let's just push. I'm just going to push this up just in case. Okay. So now let's see what this looks like. What the answer array looks like. Good. So we have that. Just like we expected. Let me just show you something awesome that you could refer to because I realize this code could be kind of dense. It is coming from my weird brain after all, so it might be like, what is she really doing here? This thing called Python Tutor. There's a JavaScript section you could go to, so it's not just to check Python. And it parses through your code in a visualized manner. So I could just insert that here. And you just visualize execution. You wait a little bit, and you just go through each and every single step of what the JavaScript engine is doing. So that's why this problem is really awesome. It really had me thinking, okay, I need to consider really how the engine's being parsed. And you have to do that for every solution. But this one in particular really involved me in that. So yeah, we could go through it, but our code is not quite done because I'll show you in a bit why that is. Let's paste in our code here. Oops. So we didn't pass all the tests because we have these weird test groups here. Let's see. So let's pick out a test case that didn't work and analyze what's happening with that. All right, so let's look at this array. We have 1, 2, 3, 4, 5, 6. We have a 6-element array. And the second argument is saying, hey, break it up into groups of 4. That doesn't make sense. 6 is not divisible by 4, so we can't have an even amount of groups. But what they expect is they have the first subgroup being comprised of that 4, but you get the remaining 2 elements and you just put that into an array and call it a day. So these directions sucked because I was all set on this, but you know, we have these weird test cases. But that's fine. It's more practice and that's good for us. So let's go practice. That with that in mind. So really what it's saying is we're considering that the array is not divisible by the second argument here. And let's write some code to make it fulfill those outlier cases. Now let's see. So let's write an if statement. If r.length divided by size does not equal 0, meaning that it's not evenly, or like there's a remainder involved. So like here we have a 6-element array divided by 4. That's not going to equal 0, right? That's going to have a remainder. We're going to do some stuff to it. We're going to consider that differently. So let's do some, again, let's quantify this situation in such a way that whatever code we write is going to apply to any of these outlier cases and hold true. So what we're really trying to do is say, okay, let's look at this number here, 4, and let's figure out like how many groups of 4 we could possibly make. So how many groups of size can we possibly make in any array we're given? Okay, so let's think about that. 1, 2. So we're gonna only go up to here. All right, so let me think. Because, yeah, some of the test cases are weird, so I don't want to just consider that. Let's look at this other test case. So this is another one. Oops, that's the result. I don't want that. And full disclosure here, this isn't exactly the best practice. If you're practicing test-driven development, you don't want to just look at all the different cases at once. That's too complex and it's too confusing. So you really want to just tackle each individual test case on its own. However, I did this algorithm earlier today, so I want to just cut to the chase here. So we have 1, 2, 3, 4, 5, 6, 7. We have a 7-element array, groups of 3. So that means here we could have 2 groups of 3 and then 1 group of 1. Okay, so that clears things up a little bit. Now let's think about that. Okay, so I'm going to declare a variable. I'm going to call it var remainder. What that's going to equal to is r.length, okay, divided by size, and we're going to just get the, what's the word? This room is so hot, I don't know what the word is. You know when you, not remainder, you round down, we're rounding down whatever this non-integer is ever going to be. So, yeah, please excuse my delusion right now. Let's see, I'm going to comment this out. I just want to see what remainder looks like. Okay, so remainder is going to look like 2. Great. So let's see what remainder would look like with this here, this argument. It's going to be 1. Perfect. So notice how in this first case, we want to grab the 2 last elements, okay? Notice that we return the number 2 here with remainder. And then with the second one, the second weird test case, we're going to get 1, 2, 3, 1, 2, 3, 2 groups of 3, and we're going to have 1 random array with just 1 element. And we get the number 1. So that's exactly what we want. Okay, so that's just like getting us closer to our solution. So the goal is we want to go through this whole process, yeah, but we also want to just grab those outliers because this is going to neglect whatever doesn't fulfill the size requirement, okay? So then what we're going to do is we're going to do answer.push, okay? We're going to do r.slice, and we are going to go as far as, let's think about this. Remainder, well, it's remainder the r.length minus remainder. r.length minus remainder. And then we're going to go as far as r.length. Let's see if that works. Cool. So this is exactly what we wanted. This is the output we wanted with this weird test case. We have a 7-element arrays. We have 2 groups of 3 and 1 last element that's 1 array of 1 element. Let me go explain why this works. So yeah, we're pushing into the answer array, the answer. What the answer is we're slicing the input array. And the point we're starting at is r.length, so we're at the 7th point here, minus remainder. What's remainder? In this case, it's 1, minus 1. Okay, so we're trapping this element here. And how far are we going? Well, we're going at the very length. And remember, it's non-inclusive, so it is just going to grab this very last element no matter what. Okay? So hopefully that made sense. Let's see if this works in all these weird test cases. Awesome. Cool. Though I am delusional and a little delirious from heat stroke, we managed to get this right. Cool. So I realized this, I'm really happy with the solution because it got me thinking a lot. I realized it might be quite dense, and I mean dense so far as like it's it's not the most intuitive code, I think. Like, I think if I were to read it, I'd like, if this somebody else did this, I'd have to really read through it and nitpick. I swear, this is like seriously like one of my favorite resources when coding JavaScript. Check it out, pythontutor.com/JavaScript. Great idea. All right, hopefully that helped you out, and hopefully you're not dying from heat stroke like I am. Okay, bye.